So welcome everyone to today's GOC43 technical session, which will be PLC programming within the CODESYS environment. So this is specifically pertaining to the GOC43. For today, we'll be going through the PLC programming languages, the PLC programming environment, as well as your hardware configuration, PLC settings, your local and global variables, your PLC programming, as well as clearing your PLC memory. So today we will mostly be working on CODESYS itself. However, there is a full presentation which will contain most, if not all, of the information I will be giving you today. But mostly we will be on CODESYS itself as we are trying to learn how to work with this environment. So I'll be starting off with the programming languages. So creating a new project, you will always be asked what programming language you want to program in. So the options, as has been mentioned in previous sessions, are continuous function chart, function blocks, instruction list, ladder logic, as well as your sequential function charts, and structured text. Now, this programming language, which you select here, mainly affects the programming language of your default programming unit or POU, which if I create the project, which it is now doing, okay, so now the project has created and you'll see there is a default POU named PLC underscore PRG. And as you can see, it is the programming language for this POU is ladder. This is due to the fact that I just selected it. Now, to start off with your PLC programming environment, we have your menu bar at the top where you have file, edit, view, project, some function block, ladder or instruction list options, build, online, debug, tools, window, as well as help. The toolbar underneath the menu bar is where you have some shortcuts where you can save your project or find certain devices, or even go online and start running your program. Right underneath it is a section of the toolbar where you will generally find some of your programming elements shortcuts, such as inserting a contact or coil, adding branches, inserting a box for a function or a function block, as well as negating or setting a contact to your edge detection. On the left-hand side in the device window is where your device tree is, or you can also refer to it as a project tree. On the right-hand side, you have your toolbox window where you can find the programming elements when you expand the options. In the middle, we have a programming workspace. So this is where you would be dragging and dropping your ladder, or if you have structured text, this is where you'd be typing your code. At the top here is where you would declare your local variables. So when I say local variables, this is specifically the variables for this POU. If you create another POU, you'd have another area specifically for that POU where you can declare variables. Having said that, there is also a global variable list, which if you go to your application in the device tree, you'd see GVL right here, and that is your global variable list. Here you are able to declare global variables, so variables that can be used in any one of your POUs. So for the environment of CODESYS when coding, this is where you mainly be working, but there is another important part where you'd be setting up or configuring your device as well as your communication and so forth. To open this device editor window, you go to your device tree. At the very top, you see device, and double clicking on that will open this window for you. So in your device editor, you're able to set up your communication, set up your hardware, set up data logging and configuring your alarms, as well as your data logging and even your analogs. So for the first tab, which is your communications tab, this is where you'd be setting up the communication or the connection to your GOC from the PC. So that is to be able to download or upload programming to your GOC. For the hardware tab, this is where you'd be setting up your extension modules. For your files, this is largely to see what files are on your GOC. The log tab allows you to see events of for your GOC, such as resetting the origin, which is basically clearing your PLC, or warm start or cold start. It will all events, as mentioned, will be logged in this window. Your PLC settings is where you set up your default or your settings for your PLC, how it will function. The parameters configuration window or tab allows you to configure your high-speed counters. So your high-speed counters would be the first option which you can do, and also allows you to configure your built-in analog inputs. The next tab, which is your backup tab, allows you to set up settings for your backup and restoration of your project on your GOC. So that includes setting up a password. This will also allow you to back up and restore your program. The next one is data logging. In this tab, you set up your variables you want to be logged, as well as the settings for each of the data logging groups. So each data logging group has its own settings. The next tab is the alarm configurator. This is where you'd be setting up variables or alarms for your GOC. The IO mapping allows you to view the IO that is mapped to your built-in digitals. The next tab is your IEC objects, which you're able to monitor when online with your GOC. And last but not least, you have your information tab, where you just are able to see some information of the device. So it's a GC43, you can see vendor, category, ID, version number, and so forth. So to start off, we'll be doing a hardware or configuring the hardware for our GOC. So to configure hardware, you select either of the extension slots or the COM slot, which you'll see is highlighted red at the edges. By right-clicking, you're able to plug in a device. So currently on the GOC I have next to me, we have installed a analog input card, which is this one right here. So you select the card and say plug device. When you have said plug device, it will show up on the visualization on the hardware configuration screen. Now, if you have changed the extension installed on the GOC, you are able to edit it or completely delete it. So selecting delete device will completely remove the extension module, whereas update device will allow you to choose another module to replace it with. If you've chosen another module, you just say update and it will update here. Now, to see if you've successfully added an extension module, you can look in your device tree where under the IO extensions, it should now show the module you have configured on your page. And if there's an empty slot, such as our second IO slot, it will show as empty. The same for the communications. Alternatively, you can also add modules directly from your device tree, which is here. So by right-clicking on one of the slots, so the first slot should be your IO slot 1, and the second one here will always be your IO slot 2, and this one under COM extension will be your COM extension slot. So by right-clicking on one of these slots, you are able to update device, or if it's an empty slot, you are able to select a device, plug device. So selecting plug device will also open up this window for you where you are able to choose a device. Next, another thing we need to set up is the PLC settings. So the first setting we are going to have a look at is the behavior for outputs and stop. So the GOC manual recommends leaving it on set all outputs to default. For the second setting, it's the always update variables. The recommended setting is enabled to always in bus cycle task. And then thirdly, the bus cycle task needs to be set to the main task. So one thing to note with this, these settings are suggested by the GOC manual, and it is mentioned that if the settings are set up otherwise, they might be, or the GOC might act unexpectedly or malfunction, as to say. So to give you a bit more information on why we set up our settings like this, I will just be quickly going to the presentation. So mainly we want to understand why we're setting our main task as our bus cycle task. This is because our GOC has two default tasks, the first being the main task and the visual task. So your main task is your PLC logic, whereas your visual task is your visualization, so your HMI screens and so forth. So as you recall, we set our main task to be our bus cycle task. As such, our main task is a cyclic task and is also the task that takes the highest priority. The fact that the main task now is cyclic means that it is executed on a fixed interval, which by default is 50 milliseconds. So for just a visual depiction of this, here we have our main task, which runs every 50 seconds. Now, saying this runs every 50 seconds, that does not mean that the scan time or the PLC logic is executed for 50 milliseconds. It only means that every 50 milliseconds, the PLC logic is executed. The runtime or the scan time of the PLC logic or the main task is dependent on the actual logic within the main task. The second task, or the secondary task that has lower priority than our main task, is the visual task, and this is set up as a freewheeling task. So this means that between the intervals where the main task is run, the visual task runs. But if the visual task is busy running and it comes up to a point where your main task needs to run, the main task will interrupt your visual task. This is due to the combination of the main task being set to higher priority, as well as the fact that the visual task is a freewheeling task, as in the as mentioned in the GOC manual. A freewheeling task will always take lower priority than the cyclic task, even though it has the same priority level. After the visual task is executed, a thing called PLC housekeeping is done or is executed. So PLC housekeeping is always attempted to do after each execution of your secondary default task, if no other task is pending. So if the main task is not pending to run or something of the sort, your PLC housekeeping will be attended to. The PLC housekeeping for the GOC43 mainly refers to I/O and COM extension unit management, as well as communication with external devices and communication to a PC that is running CODESYS. So a few things to keep in mind. As your bus cycle task or your main task is set to 50 milliseconds, you are able to change this value, and I will be showing you how to do this in a moment. But the manual advises you not to decrease this time, but it also mentioned that the user is able to increase this time if need be. Increasing the cycle time can sound kind of counterintuitive, so to speak, but there is a specific reason why this might be useful. This reason being that in the case where your visualization is delayed, or the updating of your visualizations are delayed. Now, reasons why this might be the case will include the number of visualization objects on a single screen, or the amount of advanced visualizations on a screen exceeds a certain number. But the main point we want to focus on today is that it might be that the scan time of your main task is too long as compared to your cycle time. So in shorter words, or in better words, this basically refers to the scan time, so the amount of time that the PLC logic is being executed in this 50 millisecond window is too large, and therefore is not leaving enough time for your visual task to be executed. If this is the case, you might experience some lagginess in your visualizations. One way to keep an eye on this and avoid this is by using the watchdog, which is included by default for your main task. So the watchdog is a bit that turns on once the watchdog timer, or the scan time of your main task, has exceeded the watchdog timer. So the watchdog timer is by default 35 milliseconds, and you are able to edit this, but it's not recommended. If you increase your PLC time, you can also increase your the cyclic time. You can also increase the watchdog timer, but it's not recommended to decrease this. So if your scan time exceeds this 35 milliseconds, there is a bit in your PLC system variables that turns on. And this bit is, so in your system variable group, sysvar CPU, and the variable BCPU stop cause, you'll find the second bit is a scan error bit. If this bit turns on, your scan time has exceeded your watchdog timer. Now, in the case where the user needs to have PLC logic running faster than 50 milliseconds, you are able to add a user-defined task. So the GOC supports 3 tasks, 2 of which are your default, so your main task and visual task, and you are able to add 1 user-defined task. Your user-defined task can be set as a cyclic task, which means you can set a time in which it needs to be executed, and this can range between 5 milliseconds and 65,535 milliseconds. So as you can see, you can set your user-defined task to run relatively faster than the main task. Now, for this, you also need to keep in mind that setting up this time, you won't be able to use bulk or a lot of logic in this user-defined task if you use a very short cycle time. As you now have a user-defined task, if you set up the priority to be higher than that of the main task, which the main task is on priority 1, so if you set up your user-defined task as priority 0, your user-defined task will take priority, therefore will interrupt the main task running. But if you set up your user-defined task to run every 5 milliseconds, and the logic or the scan time is too long, it will also not allow your main task or your visual task to run in between. So that is something to keep in mind when setting up your user-defined task. As I mentioned, you can set up any priority for your user-defined task between 0 and 31, with your main task being priority 1 and your visual task being priority 31. If you require or want to learn more about the user-defined task and in general the tasks in the GOC, there is a section on this in the appendix, which is 18.1 task configuration, and that is a bit more in depth as opposed to what is available on this presentation. So having said that, that is why we set up the PLC settings as we have done here. So for today, we'll mainly be focusing on the ladder programming elements, or just in general ladder programming. So to start off, in your ladder environment, and I believe it's also the same for your function block environment, you have networks. So networks are used to structure your programming environment, and you are able to add as many as you need. So quite generally, in CODESYS, a single network only allows one connection to your power rail on the left-hand side. So if I drag in a contact, I won't be able to add another contact connected to the power rail. In that network, I'd have to use a new network. Every network is numbered, which is useful for when you compile, as the warnings and error messages you receive will indicate what network the error is in. Now, if I just quickly delete this. So, starting with our ladder elements, we have your normal contacts, just a normally open contact, your negated contact, and you also have some options for parallel contacts. But You have more than just your toolbox to use when you want to insert contacts and even coils into your network or your programming space. So the first option you have is obviously your toolbox, which, as you've seen, you can drag and drop contacts and coils. Another option is when you are on your network or you have selected a network, you will be able to see these shortcuts on the toolbar turning blue, as I am able to now add it. So if I select there and select a contact, a coil, it will insert it. So having a open network or new network, when I select a contact on the shortcuts on the toolbar, it will automatically insert it. So if I want to add another one, select the point there and it adds it for me. Another option, if you don't want to use the shortcuts on your toolbar or your toolbox, you can right click on the network and say insert coil, or if you click on the rung itself, you can say insert contact or insert contact right or parallel and so forth. So if I say parallel above, it will create this type. So for you have also another option for inserting some contacts. You can use keyboard shortcuts. So for a normally open contact, that would be K, Control and K, and pressing N. Apologies. So pressing / when you have a normally open contact selected will negate or create a normally closed contact, and selecting P will create a rising edge contact, and N will create a falling edge contact. Now, similarly for your coils, you can drag and drop. You can also use a shortcut for a contact, which is Control A, and pressing S turns it into a set contact, and pressing R on your keyboard turns it into a reset contact. So next up, we have our timers. Okay, so you have some more options in your ladder elements of your toolbox. Mostly you have your time on, time off, timers, and your count up and down counters, and you have your standard or your move function, which should be familiar to most. So the timers available in CODESYS are a time on timer. This is a timer that delays turning on an output until the time that has been set has passed. So after let's say if I set it up for 5 seconds, after 5 seconds, the output will turn on. And one thing to note with your timers in CODESYS, it's a function block, so you have to give it an instance name. So if I name my instance, well, let's name it instance 1. So every time you add a timer to your programming workspace, you will have to give it an instance name. Something interesting to note, you are able to retain the function block, so retain all the information within the function block if you'd like. But today for now, we aren't going to do that. So I have given it an instance name, and you'll see it appearing in the local variable POU of the POU. And it will also show, So as I said, we also have a time or T off or timer. This timer delays turning off an output until a certain amount of time has passed. So if I set my time to 5 seconds, the output contact or output coil, apologies, will stay on for 5 seconds. This will also require you to give a instance name for the timer. So for your to turn on the timer or allow the time to start running, you need to enable your function block. For this, I will be using a bit or boolean, and I'll leave it as not addressed, so not in your marker memory, and we'll say so. This you need to configure a bit to turn on your timers so that your timers can start counting or counting time. Your PT input on the left-hand side of your timer function block is your preset time. So whatever time you want to set, this is where you do it. So to do this, you say T, which indicates that this variable type would be time. And you can set it as 5 seconds, or if you'd like 5 milliseconds, you can also do that. But today we'll be using 5 seconds. Sorry. And we're doing the same for the time off timer, time to off timer. So the ET on your right-hand side of your timer function blocks is your elapsed time. Now, the data is already stored within your function block itself, which if I try and browse in a variable, I can actually show you this. So here is all the variables for this POU. And if you see, you can see both of the instances of the timers we have just declared. So we have our time off, time till off, and you can see all the variables stored within this function block instance. So here we have our elapsed time. So with that, with that being said, you do not have to add a separate variable for the elapsed time, as you are able to access the variable itself within the instance. The output contact, apologies, output coil for each of the timers on the Q output on the right hand side of your function blocks. And you are able to either use that contact, apologies, that coil as I've shown you. So if I want to say enable this timer after this one, or while this one is active, I am able to do so. You are also able to add a contact directly onto this leg, as you can see right here. So if you'd like, you can directly connect a output to the timer leg. Similarly to the timers, the counters available for CODESYS are also function blocks. So that would mean they also require instance names. And we also have two types of counters in CODESYS. So let's start with our count up counter. This counter counts up from 0 until it reaches a preset value, after which the output coil turns on. So let's give it an instance name. So the second type of counter we have is a countdown counter. Basically, you give it a preset value, so let's say 10, and every time the input contact turns on, it decrements the preset value, so it counts down until it reaches 0, and in that case, it turns on the output coil. Wrong thing. So let's say okay, so giving the countdown counter an instance name, we are now able to look at the inputs. So CU on your count up and CD on your count down counter is where you trigger it to either increment or decrement. So if we use let's say CU trigger, okay. So if we do something similar to for this one and give it a trigger, okay. So for the count up counter, you have a reset. So this means once your count has reached the preset value, so counting up from 0 to whatever value you have set, you need to reset to restart the count. For the countdown timer, you have a load, so you reload the preset value as your current count value, and it will restart the counting down. So to reset, you will need a reset trigger as well. And same for the load, we will need a trigger to do this. Apologies. So up until now, I've been using the auto declare window to declare my variables, but you are also able to do this within your local POU declaration area, as well as with your global variables. I will be showing you how to do that in a moment. Okay. So PV would be your preset value. So for your count up, it's the value to which you are counting. And for the count down, that's the value from which you are counting down. So if we set, so you can either input a variable here, or you can just give it a straight number, which I will be doing now. The CV or current value or current count is similar to your elapsed time. It keeps track of what the current count is, but it's not necessary for you to add a variable there if you do not wish to do so, as you can access this current count or current value from the function block instance variables itself. So the Q for this is also your output coil, for which you can also add a coil to the output itself, or you can access or reference this Boolean or bit elsewhere. So that is what you'll mainly be using with your ladder elements toolbox. Next, we go to some of your mathematical operators. Your mathematical operators are your basic arithmetic as well as your comparisons. So for your arithmetic, you have add, subtract, multiply, or divide, which are fairly straightforward. The mathematical operators are different to your timers and counters because they are functions, not function blocks, which mean they don't store any variables within them, as they don't have any, they don't require instance name as well. So for the mathematical operators, you generally have an enable with your inputs. So whatever left side would be your inputs, right side would be your outputs or output variable. And as you can see, for the add function or add, we have an option with 2 inputs or 3 inputs. But specifically when it comes to your arithmetic, your add as well as your multiply can have more inputs. So the user can, or you can add more inputs by right-clicking on the function and saying append input. Doing this, I am able to add more than 3 inputs, which will all be added up together and stored in the output variable that you enter on the right-hand side. So for this, you will be required to add a variable for every single one of the inputs as well as the output, because of the fact that it is a function and not a function block. So one thing to note, as I said, the appending the inputs, it's only applicable to your add and multiply, not to your subtract. And it is also not applicable to the divide. As you can see, there is no option to do this for those mathematical operators. Then apart from the arithmetic, as I said, we have our comparisons. So you have your equal, not equal, less than or equal, greater than or greater than and equal. These blocks or functions, these functions compare the 2 inputs and give a Boolean or bit output, so true or not true output. So for that, you have variables as your input, so word variables, and as your output, you'd have a coil, or you'd further your branch with a contact. You are able to add a inline or the comparisons without having it to be enabled, which if you'd like to do this, you'd have to add a box, and within the box you can say EQ, and you'd see now you have a comparison that does not need to be enabled. Alternatively, if you just drag and drop it, you'll always have your enable option for your comparisons. This is also applicable to your arithmetic functions, but you can also always use true, and it will always stay true. Or there's also a always on for the GOC, which I will be getting to in a moment. but you can always do that as well. So that is for your mathematical operators. Next, we have our Boolean operators, and this should be be familiar to everyone. We have our AND, our OR, and our exclusive OR. Now, similarly to your mathematical operators, this is a function, so it doesn't need an instance name, and can also be used as a function without an enable. Similarly to your add and your multiply, you can append the inputs to have multiple inputs to the function, but you'll always only have one output. This output right here. So you'll always have to add variables to each of the inputs and outputs, otherwise you will get errors along the way. Now, this in general will cover most of what you will need for programming, but there's one thing that I still want to point out is your conversion. So if you ever require to change let's say, a double word to a word or something of the sort, you'd use the conversion operator, which is under the other operators section. And this will allow you to convert the variable types as long as it is accepted. So that is how you just enter the variable type, let's say D word, from which you want it to be converted to the variable type that you want it to be converted to. So input the variable from which that is stored as a D word, and on the output side you give a variable that is for where it would be stored as a word. You can also add this as a function without an enable. So I would like to now point out the hardware or the digital inputs and outputs that are built in. So as I mentioned previously, you can see the mapping for this in your device editor window under the IO mapping tab. So if you want to reference any of these or use any of your built-ins digitals in your program, you are able to browse them in as follows. So if I insert a contact right here and press on the ellipses right here, I open the input assistance or assistant window. From here, you're able to access your variables that are available for your POU. So this is something actually important to note. If you are working within a POU that is in a POU and you have multiple POUs, you will only have access to variables either in the global variable list or the local variables. So in that POU's variables. So here we can see global variables, which there are two options. One being your IC objects mostly, so that you can see your system variables as well as your IC objects that include your high-speed counters and base analogs. But we are looking for our built-in digitals, which would be under the globals mapping option here. So IO config _globals _mapping. So to browse in a built-in digital, this is where you would go looking for it, which you can see. So you'd be able to see the symbolic name or label that is given to the built-ins by default, which is underscore DI for an input and underscore DO for a output. So if we select, keep in mind that if you have a GSC that has 8 inputs and 8 outputs, you'll still have the option for digital input 10, 9 and upwards, as there is no differentiation between the two types, so between a 8 input and 16 input, or 8 output and 16 output GOC. As such, if you use these, it will have no effect. So keep that in mind if you have an 8 input, 8 output GOC. So I will be choosing a digital input 7. So you are also able to type in the symbolic name right here if you do know what it is. So for instance, if I want to use the digital input 6, I can do that as well. Now, the default symbolic name can be changed. So for instance, if I browsed in digital input 7, if I change it to something of the sort, so now, because I've already used it in my program, CODESYS will ask you to refactor, which in short means it's going to replace all the old variables of that name to the new version. So if I say yes, it brings up a pop-up screen and shows me where this is applicable. And if I say okay, it will replace the old with the new. So just to show, you can also add custom names to your built-ins and use that in your program. The LED keys are similar to your built-in digitals. They also have input bits and output bits. And to see the I/O mapped to the LED keys as well as your quick access keys, actually, you can find this in your device view under keys underscore LEDs right here. Double clicking on this will open the window you see now. And under the I/O mapping tab, you will be able to see the I/O mapped to these keys. So we have input bits for each of the keys and output bits for only your LED keys, 4 being for green and 4 being for red. So to use this in your program, it is similar to the digital built-in digitals. You can also find them under the globals IO or global mapping section, and you'd see key F1. So this is its symbolic name or default name. So if I want to, let's say, turn on the green LED of key 1 of the LED keys, I can select it. So when these two contacts turn on, the green LED will turn on. Now, as with the built-in digitals, you are also able to rename the input and output bits for your keys, which once again, it will ask you to refactor if you've already used it in your program. As you can see, that is what has happened here. Now, I mentioned previously um, uh, con that the GSC also has a version of always on. So those familiar with the standard mouse PLC ranges might be aware that there are special registers or special bits available within its memory or CPU, which one of them is always on, and you also have a few clock um, clock pulse bits. Now, something similar is available for the GOC, which, if I show you where to find it, is part of your system variables. So those who recall last session, we spoke about system variables available. There is a system variable that specifically has the functions for always on in the first scan, and so forth. So to find your system variables, you go to the ioconfig_globals, not the mapping option. And you generally have to know specifically what system variable group you require. So for our one, we are looking for, it's under sysvar CPU system bits. And just as a summary for you here, bit 0 is the always on bit, bit 1 is your on for the first scan cycle, bit 2 on in case of a warm start initialization, bit 3 is on in case of a cold start initialization, bit 6 provides a clock pulse of 500 milliseconds, and 7 a clock pulse of 30 seconds. And bit 8 provides a scan cycle that is the same length, clock that is the same length as your scan. So to access these bits, you go to sysvar CPU and we look for system bits. Now here you can also actually see a small description of what each of the bits do. So as you see, 0, always on, and so forth. So you aren't able to select bits from your input assistance window here when it is a word variable. So to access the bit, you'd have to use a dot operator and give the bit number. For this case, we want always on. And then it will look like this. If you browse in your system variable, so let's browse in the same one without adding a dot operator to indicate what bit you want to use, it will not work as well. As you can see, there's no longer contact. Let me undo this quickly. Okay, so to show you a bit better, I can try and do it in a new network. So once again, trying to browse in this system bits. And if I don't add a dot operator to show you what bit I want to use, it will not work because you're trying to browse in a word for the application of a contact. So it's always important to add the dot operator and bit number after you've browsed in your system bits. So for the purpose of today, I'll just be going to browse in a okay. One thing with the LED keys to keep in mind is you have two types of output bits for the LED keys, one that turns on the green LED, one that turns on the red. But turning on both at the same time actually turns on a yellow LED for the key. So that is a functionality to keep in mind. Now, if you've noticed in my CODESYS, the gray blocks and the comments appearing above the devices, this is actually the comments we've been adding to our variables. So if you see here, so let's find one quickly that is easiest. Okay. But yeah, so you are able to see your comments that you have set in your variable or low variable areas, either in your global variable list or your local one, in your programming software or programming workspace, if you have set the visibility. Now, I will be going to show you where to set the visibility of these comments, and where applicable, I have also have the visibility of the device addresses on. Now, this is only applicable to variables that have addresses. So for instance, my input bit here, as well as my LED keys, will have addresses, or if I have declared a variable in the marker memory, it will also show. But those that don't have specific addresses, therefore are in your data memory type, will not show it. You also have the option of naming or giving a title to your networks, and also giving a comment to your networks. So if you see here, what I've currently selected is the area in which you would be able to give your network a title. So if I say this is timer on example, this is your network title. You'd see it appears in black and is underlined. Underneath it, typing in here will show in green, as this is your network comment. Like that. Each of your networks can be given a title as well as a comment. Generally just this helps with readability of your program, and in the end it will help with troubleshooting as well. Now, to toggle visibility of all these options on and off, you can go to Tools in your menu bar, Options, and then if you look here, it's a FBD, LD, and instruction list or LIL editor. And in the Generals tab, you'd see options for show network title, show network comment, a few other options, as well as show symbol comment and show symbol address. So for instance, if I don't want to see the symbol comments, I deselect it and press OK, and you will now no longer see any symbol comments. So that is specifically variable, your comments for your variables. You will no longer see in your programming workspace. But as you can see, I have not deselected the address, so that is still visible. So to customize your CODESYS user interface, you generally use this options window under your tools. So as you can see, there are also some settings specific to each of the programming languages, first being function blocks, ladder, instruction list, and so forth. Now for your some of your other languages, they have an entirely separate settings, because the programming environments do differ between languages. As you can see, here's your sequential function chart settings. Now, that's another thing to note. When selecting different programming languages, your interface actually looks slightly different. So if I add a POU, which you do by right-clicking on Application, Add Object, and POU, I'm able to add a POU that can be in another programming language than the default, so than ladder that we currently have selected. So if I choose, for instance, function block diagram and say give it a name and say add, it will now show up in the device tree. But as you can see, it doesn't look a lot different. It actually looks quite similar to the ladder, but in our toolbox, you'll see no option for contacts or coils, as well as in our shortcuts up top. You won't see options for contacts and coils. If we, for instance, add a structured text, POU, it will also look different. So let's select structured text. I can see we don't have anything in our toolbox, and the programming environment no longer has networks. It's almost a text field. So that is one thing to keep in mind. With every programming language, the interface does change slightly, but that's mainly your programming elements toolbox and your shortcuts on your toolbar. Now, if we upload our program to, download our program to the GOC, we have to bold. If you ever bold your program or rebuild your program, you have your bold messages pop up in this window. This is also where you can access your watch window. So if there are any errors, it will show up here. So now, you are able to monitor your PLC logic while you are online with the GOC. So for that, we first need to be online, and to be online, we need to set up our connection right here. So now I'm connected to the GOC and I'm able to download my program, which it is now currently busy. So another thing I'd like to point out, if you take a look at my device tree at the moment, you'll see the default POU PLC underscore PRG in blue, and the other two example POUs that I added are grayed out. So the fact that those two are grayed out indicate that they are not used within the project, so they aren't set up to actually be run, so the logic will not run. This is important to know for if you, for instance, missed or did not call this logic or add this POU to your main task. So just know that if this is gray, it will not be running, the PLC logic will not be running on your GOC. Okay, so when you are monitoring, once you've downloaded your program and set it to run, you can use CODESYS to monitor your PLC logic, as you can see here. Now, how do you know that you're busy monitoring? For one, your login button here will be grayed out, and you'd have the option to log out, so stop monitoring. You'll also see your device up here being green, as well as your application. And you also see some green icons indicating that the certain parts of your GRC are healthy. Another thing is you'll see the ladder rungs being blue, as you see here. Now, all the variables declared within your local POU. So if I am monitoring this POU, all the variables I've declared within that variable area or local POU variable declaration area, I am able to view here. If you want to view something specific, you can add it to your watch window right here. Now, when monitoring, you are able to force or write values to simulate kind of your program or test your program. So for instance, if we want to start our timers, so we want to turn on this bit, I need to write or force a variable. Now I say write or force because CODESYS has two different options. You have your write all values of device application or force all values of device application. The main difference is write is mainly used for any variables that aren't physical, so not your input variables, built for your digital inputs, because you need to use the force specifically to force those values when it is a physical digital input for instance. So let me just show you. If I say write all variables, so we didn't give a address to in timer, so it's data in the data memory. It's completely within the GSC memory. So if I say write, it will now apply that to it, and it will enable our timers. Now, if you see, you are also able to see the elapsed time and see whether the contact is on or off. So if I want to turn off this contact, you set the value in your prepared value column, right click on your programming area and say write all values. Now you'll see it resetting. When it comes to digital inputs, for instance, our input 7 and 6 we have here, you have to force it on. So use the force option. So you'd still go to where the mapping is. So for this, you can either do it in the watch window or in the mapping, but you select what variable you want it, what variable you want. So we want this one, and we want it as true, as well as digital input 6 and true. Now, going back here, if I say force all values of device application, it will now force those to turn on, which you can see here. Now, if I quickly go back to my mapping, now you'll see an F symbol show up. That is to indicate that it is forced. To unforce a variable or these variables, you right click on the programming space once again and say unforce all values. And now you can see it turns off, and it's no longer the case here as well. Now, as an example, if I only try and write and not force these values, you'll see it doesn't turn on, even though I've written it. That's because it needs to be forced because it's a physical input. Lastly, as you can see, the always on is doing exactly what it should and being always on. Now, I previously mentioned the files. So yeah, I'm in this tab, I'm able to see the files that is currently on my GOC. So an important thing to note is when you download data, application data to your GOC, such as text lists or some visualization objects like images, like you can see here, there's a few text lists and things currently on the GOC. They aren't automatically deleted when you delete it from your project. You have to manually delete this, which for one, I can do right here. As you can see, if I select a text and say delete, it'll ask me if I want to delete it and say yes. And if that's the case, it is now deleted from my GOC memory. So on the right hand side here, this is your GOC memory or files, and this is your host or your PC files. This is also a good way to copy files from the GOC to your PC. Now, if you don't want to go and individually delete some of the application data, you can bulk reset it or delete it by initializing or clearing your PLC or your GOC. This is done by going to online and saying reset origin. But doing this completely clears your GOC. So you need to have backups in place before trying to do this. So if I say this, it will now reset origin and it will now start clearing my GOC. Okay, it is finished. And now if I go back to files and say refresh, so it's important to say refresh, otherwise you can't always see. You can now see it's empty. The previous file where you saw images and text lists is now empty because all of it has been cleared. This also means there's no program currently on the GOC. So to do that, I'll have to log out again, log back in, and re-download the PLC logic to the GOC. And with that, that is actually the end of our session today. The next session will be on HMI programming within the CODESYS environment. So then we'll be mostly focusing on how to do the HMI side of the GOC